All right, today we're going to be talking about vectors. And vectors have two important qualities. One, they both have a magnitude and they have direction. And yes, you probably are thinking about a movie that I can't mention because I don't want any copyright people, right? But if you're doing things, sometimes you got to do things with magnitude and direction, okay? Whenever you have a vector, you have an initial point and you have a terminal point. Initial point is where you start, and the terminal point is where you end. All right, that's what they call terminal diseases. They're not good, okay? Because that's where you're going to end. All right? They call them terminals because you're playing flies and you end up at a terminal. I don't know why they call it. I mean, I know you can start at a terminal, but you can also end at a terminal. Now, components. If I say vector AB and I start here and I end here, we have this part is called the change in X, and this part is called the change in Y. You'll notice the change in X is happening here, the change in Y is happening here. So we have a positive 5 and a positive 8. Those are the components for vector AB. But this vector AB has two different components. It's actually going 5 to the left and 3 down. So these components you can see are different because A right here, that is the initial point, and B is now the terminal point. Okay, so we're going to look at in the Khan Academy. We're going to look. There's a beautiful golf course. Played it. Equivalent vectors. So if we look at these right here, we're looking at vector U and vector W. You can clearly see that they both go down the same amount and they both go over the same amount. They're down 1, 2, 3 over 1, 2, 3, 4, 5. This one also goes down 3 and over 5. So I'm going to say these vectors are equivalent because they have the same magnitude and direction. They both go down 3 and they go over 5. This also goes down 3 and over 5. So I'm going to say yes, they are equivalent. Woohoo! All right, let's take a look at these. These vectors are not equivalent. You can clearly see they're not equivalent, but I'm going to, hopefully you guys will see right here. This goes up a certain amount and then over a certain amount. Okay? This goes up and over. Now you can also, probably better to interpret them left and right than up and down. It goes over 3 and up how much? 1, 2, 3, 4, 5, 6. So this vector goes over 3 and up 6. This vector goes over 2 and up 4. So this goes over 2 and up 4. So those are the components for vector u. Now they actually are going in the same direction. So you can clearly see like these have, if we looked at the slopes, they still go up 2 over 1, up 2 over 1. This goes up 2 over 1, up 2 over 1. So they're going in the same direction, but they don't have the same magnitudes. This vector has a greater magnitude than this one. And so they have same direction, but they have different magnitudes. Well, these are just all over the place. They don't have the same magnitude and they're going in different directions. So I'm not even going to show you like that goes to the left a certain amount and up. This goes to the left and down. So they are not equivalent. They have different magnitudes and they have different directions. You can clearly see that. Okay, let's check this one out though. So over here, we go over 3 and up 1, 2, 3, 4, 5. Here we go over 3 and up 5. So they have the same, looks like they have the same magnitude. That's a 3, 1, 2, 3, 4, 5. That's negative 3 and 1, 2, 3, 4, 5. So they end up having the same magnitude, but they're going in different directions. So same magnitude, but different directions. Okay. So what are the components of vectors? Okay. So if you have vector AB, and it has an initial point. That's your initial point A. So your initial point A is at -9 and an 8, and it has an x component of a +4. That means I get to add 4, which puts me at a -5. And it has a y component of -11, which means I get to take away 11. That puts me at -3. So if A is my initial point, B would be my terminal. Okay. There we go. That's my terminal point. So I'm just going to type in a -5 and a -3. Okay, so I'm going to put a -5 and a -3. Okay, let's take a look at this one. It says find the components of vector A, B. Now it's very important that you know where your initial point is. By the way, whenever it leads, that's always your initial point. If it said vector BA, then I'd start at B, but it says vector AB. So this is my initial. So I'll put initial, and then this guy's my terminal. Okay, so how far does it go to the left? I'm just going to make my little right triangle. So it looks like it's only going 2 units to the left, so I'll put -2, and it's also going down 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going down 9 and 2 to the left, so I'll put -2 and -9. There's the -9, and there's the -2. You're like, man, this is easy. You're right, it's not that bad. -2, -9. All right, last one. Okay. It says vector AB has an initial point. So vector AB, so the initial point at A, at 7 and a -4. And I got to find B. So it has an x component of -10, so -10. 7 minus 10 is -3. And it's got a y component of -5, so it's -5. But it had -9. There we go. There's the start, there's the finish. So -3, -9 should be my answer. Okay. Okay. Now we're dealing with magnitude. Here's the last and final one. So what would be the magnitude of vector u, the magnitude? So we've got to find our components first. There's my components. So if I were to write, I'm going to call this A, and I'll call that B. So instead of vector u, I'm going to call it vector AB. Looks like I go 3 units to the right, and I go down 1, 2, 3, 4, 5, 6, 7. So I go down 7. If I want to find the magnitude, I take the change in my x's and I square them. I take the change in my y's and I square them. Parentheses do matter. If you don't think they matter, then try doing it without parentheses and see what happens. So that becomes a 9. That becomes a 49. And then you get the square root of 58. And it says, enter the exact answer as an expression with a square root symbol. So that's what I'll do. Square root of 58. Let's see if I did it right. If not, you can laugh at me behind my back or laugh at me in front of me. Oh, man, I got it right. Okay, here we go. Ooh, I've got a vector. It gives me my components. Well, that makes it even easier. I don't even have to interpret anything. So what's my first component? -7. What am I going to do? Square it. What's my other one? 2. What am I going to do? I'm going to square it, put it underneath the square root symbol. So it's like just basically the distance formula or Pythagorean theorem. Got 49 and 4. So that gets me the square root of 53. And that's all I'm going to type in right there. The square root of 53. radical 53. Okay, that's how you get the magnitude. And let's go over here. Let's do one more. All right. So here we have an initial point of a 5 and a 1. And then the terminal points at a -3 and a 4. So what happened? What's the change in my y? It looks like it went up 3. What's the change in my x? It went from 5 all the way down to a -3. So it looks like it dropped 8. So all I got to do is take that -8 and square it. Take that 3 and square it, and I'm done. 64 plus 9. That ends up being the square root of 73. Just whatever the gap is between the numbers, just make sure you square it, add them together, and that's your final answer. Square root of 73. And I'll do one more that deals with a graph. So when you're looking at a graph, just make a little right triangle. Make a little right triangle. Find your components. So here it goes 3 to the right. Here it goes down 1, 2, 3, 4. So it goes down 4. So all you got to do is take the square root of 3 squared plus -4 squared, which gets you 9, plus 16, which is the square root of 25. But that is just your basic 3, 4, 5 triangle. So the magnitude is just 5. Since it simplifies nice and neat, I'll just type in a 5 and call it a day. All right, and that's it. Hope that was helpful. Have a good day.